Welcome to The Explainer. Today, we're digging into something that might just change how you think about AI, a kind of superhuman memory that's unlocking a new way for these systems to think. So let's just jump right in with a big question. We talk a lot about superhuman AI, and we usually think of, crazy reasoning or speed. But what if the first truly superhuman ability we're seeing is something else, something more fundamental? And the whole thing really starts with this one giant number, 1 million. That's how many tokens, you can think of them as pieces of words, that the newest AI models can hold in their memory, their context window, all at once. To put that in perspective, that's like feeding it several books or an entire software code base and having it hold all of that in its active memory. And this is where it gets kind of wild. Look at the difference here. Our own short-term memory, the stuff we can actively juggle in our heads at one time, is famously tiny, maybe 7 things, give or take. An AI with 1 million token context isn't just a little better than us. No, it's playing a completely different sport on a completely different planet. So yeah, what we're talking about here is a truly superhuman working memory. And a lot of top AI researchers think this is maybe the single most underhyped, most important development in the entire field right now. Listen to how AI researcher Sholto Douglas breaks it down. He says it basically solves the onboarding problem instantly. You know how it takes a person weeks or months to get up to speed on a new complex project? Well, the model just reads the manual, the whole thing, in one go, and it just gets it. And check this out, because it's not just about raw memory. This one experiment is incredible. A model was given a bunch of examples of a super rare language it had never, ever seen before in its training. And just from those examples in its context, it started translating that language better than a human expert. It learned a new skill on the fly. Okay, so a superhuman memory is one thing, but how does that actually translate into something even crazier? The ability to learn new things without going through the whole slow, expensive retraining process. Well, it all comes down to this idea called in-context learning. Basically, the model uses all the information you feed it in a single prompt as a sort of temporary textbook. It learns just from those examples for just that one conversation, and it fine-tunes itself in real time without permanently changing its brain. But how is that even possible? Well, a really cool theory is that the model's attention mechanism, that's the part that decides which words to pay attention to, is actually doing something that looks a lot like gradient descent. And gradient descent is the core learning algorithm for all of modern machine learning. So it's like the AI is running a mini, super fast training session right there in the moment. Okay, and this is where my mind kind of gets blown. Because if an AI can learn like this, it makes you wonder, right? Is this how our brains work too? Are we just doing a biological version of in-context learning all the time? You've got researchers like Trenton Bricken putting forward this pretty wild hot take, as he calls it. He's saying, what if what we call reasoning isn't some magical, logical process? What if it's just really, really, really good pattern matching, built on all the memories and associations we've collected our entire lives? Think about it like Sherlock Holmes is actually a perfect analogy. What does he do? He gathers clues. That's his context window. Then his mind just constantly queries those facts, weighing which ones are important. That's his attention. He's not using some secret logic. He's just running a powerful search across all the data he's holding in his head. And what's crazy is that the science is starting to back this up. We're seeing this incredible 3-way connection. There's a core circuit in the cerebellum in our brain, which holds 70% of our neurons, by the way, and it turns out it's mathematically identical to an old computer science algorithm for associative memory. And that same circuit is also a really close match for the attention mechanism in modern AI. It's wild. Okay, so if all of that is true, if these models have superhuman memory and a learning system that looks a lot like our brains, it leads to a really obvious question, right? Why haven't AI agents just taken over everything? Why do they still fail at complex long-term tasks? It turns out it's not about the memory. The bottleneck isn't about understanding a long-term goal. It's about something much more brutal: the need for near-perfect reliability. For an agent to actually work, it can't just do one thing right. It has to do hundreds, maybe thousands of things in a row, flawlessly. And this chart, wow, it just lays out the brutal, unforgiving math of it all. Let's say your AI is 99% reliable on any single step. That sounds amazing, but your chances of it completing just 10 steps in a row already dropped to 90%. And for a 100-step task, you're down to a 36% chance of success. That tiny 1% error rate gets magnified into total failure.
So, if it's not about the AI's ability to think long-term, what's really holding everything back? What's the real bottleneck stopping the next big leap?
You always hear the same list of usual suspects, right? People say we're out of new ideas, that engineering is too slow, or that we're all just waiting around for some genius to invent a brand new algorithm.
But if you talk to the people who are actually building this stuff, they'll tell you the real bottlenecks are much, much simpler. It comes down to two things: raw compute power to run the massive experiments you need to, and something they call taste, which is basically just the intuition to know which experiments are the right ones to bet all that expensive compute on. And that really leaves us with this one final, kind of mind-bending question. If intelligence isn't some magical spark of logic, if it's really just built on memory and making connections, what happens when we build machines that are just fundamentally better at remembering and connecting things than we are? What comes next? That is the big question. Thanks for joining me on The Explainer.